then finally, if we wanted to know the maximum elevation, that's where our velocity in the y direction is 0, so we can find the time when the velocity in the y direction is 0, and then solve for that height. So you just kind of manipulate those equations. I can do another example if anybody, do you need practice on that, or are you good?
I'm good.
Pretty good, okay. This one is if you were doing it at the same elevation. This is kind of a weird one. If you were launching it and it hit at the same elevation, the 45-degree angle would give you the largest range. Okay? But because its elevation is a little bit down, you actually, if you launch it less than 45, it'll actually go further because of that drop in the position there. So this is another example. I'll let you look through that example if you, but basically again, you're just figuring out what you have and then solving for what you need. So in this case, again, you could solve for the time, which you do quite often, and then in the x direction, you can figure out what your initial velocity is. Okay, so this is something that is a little bit newer to you. So projectile motion, your acceleration was, either in the x direction. So in projectile motion, you had an acceleration in the y direction. If you have circular motion and you have a constant velocity, which is pretty much all we did in 1510, which direction is its acceleration? If it has, even if it has a constant velocity, it still has an acceleration because, yes.
It goes tangent to it.
Yes. So we'll have a tangential, an a sub t, which is due to dv dt. Okay, and we also have what we call a normal or centripetal, or I always forget which book uses what name. So they call it normal. We'll try to maintain some consistency there. So in your other text, it called it a sub c, which is the same as a sub n is equal to b squared over r, or omega squared times r. Okay? So if you were to use